A man sees a bus accelerating uniformly from rest at a bus stop, 15 meters away. He then runs at a constant speed and just catches the bus in 30 seconds. Determine the speed of the man and the acceleration of the bus. And then there's another part. If the man's speed is 3 meters per second, how close to the bus can he get? All right, so there's two different parts to this question. And so in the first part, the man catches the bus, just catches the bus. So when he catches the bus, they're at a particular point. We're going to say that their velocity is the same. And so let's call the velocity at this point what's unknown. So we'll call it P. For the man, he's running at a constant speed. And so we know that the velocity is distance on time. Okay, what do we know? We know, well, the time it takes for him to catch the bus is 30 seconds. We also know nothing. We know the velocity he's traveling at, we said is going to be p, and therefore the distance till he catches it is velocity times time. So let's say it's 30p. That can be helpful to us. So that's the distance from where he is now to where x marks the spot. And for the bus, what do we know? For the bus, we know the initial velocity is 0. It starts at rest. The acceleration, we don't know. We have to find the acceleration. The time, well, the time until the man catches the bus is 30 seconds. They both start at the same time. So we know that. And the final velocity is p. So when they just catch, then they have to be traveling at, that word just probably means they are traveling at the same speed. And do we know the displacement or the distance? The distance or displacement the bus travels is, the person is at the origin because we made him start at 0 and we said his distance is 30 times p, which is his velocity. So we put the origin back at the man. So the bus, the displacement of the bus is going to be the distance that the man runs, and he runs from where he starts to x, minus the 50 meters. So the displacement for the bus is the distance the man runs is 30 times p, and we're going to subtract 50 because the man ran an extra 50 meters, right? So that's extremely helpful for us. Why is it helpful? Because we have the velocity for the bus in terms of p, and we have the displacement for the bus in terms of p, and that's a single variable that we can then solve things. So we can use UTVS and work out what p is, which is the velocity of the man, and it's also the velocity of the final velocity that the bus reaches. So in this case, s is equal to a half of u plus v multiplied by t. Right, and we're just using the variables that we have. 30p minus 50 is equal to a half of 0 plus v, all right, that's p, and t is 30 times 30. All right, we have got 15p on the right, 30p on the left. So if we take it over, we will get 30p minus 15p is just 15p. And let's take the 50 over to the other side, and we get 15p equals 50. Which leaves us with p is equal to approximately 3.33 meters per second, which is 10 on 3. 10 on 3. Okay, so now we can find out the acceleration of the bus, and we can use v is u plus at. The final velocity, we know 10 on 3 is initial velocity, which is 0, multiplied by the acceleration times the time, and the time was 30. So all we have is the acceleration is 10 divided by 3 divided by 30, which turns into 1 on 9. or 0.11 recurring blend there, meters per second squared. That's the acceleration of the bus, and we've done part one. We found the speed of the man and the acceleration of the bus. All right, for part two, the man is now running at 3 meters per second, which is slower than the 3.3 he needed to catch the bus. So he doesn't catch the bus, but we have to find out how close can he get to the bus if he runs at 3 meters per second. All right, so let's work with the bus. What we do know is the bus starts out with initial velocity of 0. We also know that it has acceleration that we just worked out because it does the same thing, 1 on 9. We certainly want to know the distance because we want to know how close the man gets to the bus, and it's going to have to be related also to time. All right, so for the bus, we are after some formula that relates these four things together, where we can get the distance the bus or the displacement the bus has traveled related to a certain amount of time. And the formula that is good for us is S equals ut plus a half at squared. All right, and that's nice because u is 0, and so the displacement or the distance the bus travels is just a half of at squared. And so for the bus, the distance is equal to a half of 1/9, which is 1/18 of the time squared. Right, what I've just done is I've made my origin at the bus stop. I've said that's the displacement of 0. And so the displacement of the bus is based on the bus stop. So we have to have the person do the same thing. So the person is running at a constant speed now. Velocity is distance on time, and their speed is 3. And so the distance is the velocity multiplied by time. And for the person, we know that their position now is going to be 3 multiplied by t. But it's not 3 by t exactly because they're behind the bus and we put the origin at the bus. So if we're relating these together, they have to have the same origin. They have to be referenced from the same starting point. There's 30 meters, 50 meters behind the bus. So we subtract 50 meters from the person's displacement and we'll have their position relative to the bus stop, and the bus's position is also relative to the bus stop. All right, what we're really interested in is the gap, which is the distance between the bus and the person, and we want to find the minimum distance. So we can do this by making a gap function. Let's call it GT, G for gap, and it's going to be a function of t, and our gap function is going to be the position of the bus, which is 1 on 18 t squared, minus the position of the person, which is 3t minus 50. All right, so that tells me the distance, the gap, the distance between the bus and the person. And we were told the person doesn't reach the bus, which makes sense because they're running slower than what they did before. Okay, so we have a quadratic. 1 on 18 t squared minus 3t plus 50. What we know about this quadratic is it's a smiley quadratic. It's going to look like this because the a variable, what's in front of the squared variable, the a term, is positive, so it's a smiley, which means it has a minimum. And we define this function to be the gap. And so the minimum value is going to be the minimum gap. So we're looking for the turning point of the quadratic. For the turning point of the quadratic, t is negative b over 2a, which is equal to negative 3, which is just 3, divided by 2 times a. 2 times 1 on 18 is 1 on 9, and 3 divided by 1 on 9 turns into 3 times 9, which is 27. So the time is 27, and we have to work out the gap. We just put that back into the function. So our gap at 27 is equal to 1 on 18 times 27 squared minus 3 times 27 plus 50. We put that into a calculator. We end up with a gap of 9.5 meters. Okay, that's the closest that the man gets to the bus.